Okay, and our last topic that I want to talk about for Chapter 5 is talking about electrical power. And so this slide here is titled Energy Power in the Kilowatt Hour. Just what do you pay the power company for? Do you pay them for energy or do you pay them for power? And a lot of times we might think that we would pay the power company for electrical power, but in reality we're actually paying for energy. So we have three different kinds of power plants here: a hydropower plant, a wind farm, and this would just be the traditional coal plant. And really what these things are doing is they're converting energy from one form into another. And when they supply that energy to us, they're supplying that energy via electricity. And the way that they bill us is in the unit called the kilowatt hour. And this is how that unit is actually defined. So the kilowatt hour is actually the amount of energy delivered in a 1 hour time frame to a device that draws energy at a rate of 1 kilowatt. Now, maybe the easiest way to understand that is to think about a toaster. A typical toaster has a power rating of about 1,000 watts, so that would be equivalent to 1 kilowatt. If I run that for maybe 30 seconds, which is how long it might take for me to make some toast, I don't use a tremendous amount of power, of energy. But if I run that for an hour, what I would get is 1 kilowatt hour worth of energy. So a 1,000 watt device run for 1 hour will use energy of about 1 kilowatt hour. That kilowatt hour can also be defined in terms of joules. So 1 kilowatt is 1,000 joules per second. And if I run that for 3,600 seconds, or 1 hour, that would be equivalent to 3,600,000 joules. Now this is a really large number, and so it's a lot easier for us to talk about electrical energy dealing with the kilowatt hour. So 1 kilowatt hour is equivalent to 3,600,000 joules. This little slide here is from a book that I've read recently called Energy for Future Presidents. It's just talking about the cost of energy. What's really striking by this is how much it costs for electrical, for batteries, a AAA battery, in order to supply an equivalent amount of energy that might run my toaster for 1 hour. If I use electrical energy from my wall outlet, it might cost me 10 seconds. If I tried to run that toaster for an hour with batteries, it would cost me $1,000 to be able to do that. This is just a picture I picked off the internet about the electrical power structure in the United States, and it just gives us a breakdown of the different sources that we're using to generate electricity. And you can see natural gas is at this point the largest portion of our overall power structure, or energy structure, if you will, in the U.S. Coal is very close as well. And you're starting to see more wind pop up, and nuclear is certainly something that we'll have to consider down the road. All right, and just one quick problem for us to show you how to compute energy use, electrical energy use. So you have three different devices here, and you've monitored them throughout maybe a month period, and you see that the 75 watt bulb that you use in your hallway is operated for 2.5 hours per day. The speaker system, it's 25 watt stereo that you run for 1.2 hours per day. And then the microwave, don't use it very often, maybe 15 minutes per day. And each of these are different power, they have different powers associated with them, so different rate at which they use energy. So let's determine how much energy the light bulb uses in a 1 month period. The way that you can do that is just by saying that energy is power times time. This light bulb is a 0.075 kilowatt light bulb. And if I run that for 2.5 hours per day, and I do that for 30 days in a month, what I get is an energy of about 5.6 kilowatt hours. Okay, now let's go ahead and do the same thing for the stereo. When I go through and determine the amount of energy that I use for this, again I multiply the power times the time. That's a 0.025 kilowatt device, and I'm running that for 1.2 hours per day, and I'm doing that for 30 days in the month. And what I see is that's about 0.9 kilowatt hours worth of energy. And when I go through and do the last one here, the microwave, I see that the power is quite a bit higher, 1.1 kilowatts. I don't run it for nearly as long each day. I only run it for a quarter of an hour. And when I run that for 30 days, what I see is that the amount of energy that I use is about 8.3 kilowatt hours. So again, what this does is it gives me a way of calculating the amount of energy that I use. It's not just the power of the device, but how long I use that device would be related to the energy that I draw. So what would be the electrical bill if you were billed for $0.112 per kilowatt hour? The way that we would do that is we would just add up the total energy that we would use. So 5.6 plus 0.9 plus 8.3, the total amount of energy is about 14.8 kilowatt hours. And when I multiply that by $0.112 per kilowatt hour, so $0.112 per kilowatt hour, what I see is they would charge me about 1.165 for that energy. And I'm going to go ahead and stop it there, and then we will continue this tomorrow. Go Bucks.